Hello, myself Dr. Vijay Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss regarding transform mapping. In the software development life cycle, from the analysis phase, the analysis model is developed. So, the design or DFD must be used to view the overall process flow of the application. How this DFD is mapped into the implementation or coding part to facilitate the developer is majorly focused in the transform mapping. The topic learning outcome is mapped to the course outcome of CO4, which is understand the importance and need of design, explain the various approaches of designs. The basic agenda of this video is what is software architecture, how design can be useful, and how the DFD is mapped by using the transform mapping. The architectural design is described a multi-step process in which representation of data and program structure, interface characteristics, and procedural details are synthesized from information requirement. Whatever the requirement gathered and documented in the SRS, from those the program structure, interfaces, and procedural details must be identified. The data and functional behavior domains serve as a guide for the creation of software design. So, architectural design represents the structure of data and program component that are required to build a computer-based system. So, the major components, the program is generally divided into small manageable components. How these components are placed in the architecture, how they are related, how they are sharing the data between them is focused in the architectural design. The features of architecture is analyze the effectiveness of design in meeting its stated requirements and consider the architectural alternatives. Variety of architectural styles are available like column written architecture, client-server architecture, layered architecture. So, depending upon the complexity and domain of the application, consider the alternative architectural styles and design decisions are made and the design changes are these decision making is still relatively easy with the software architecture. Reduce the risk associated with the construction of the software. The software architecture is majorly connected with the factors like the IT environment, whether the application is a two-tier, n-tier, the architecture and IT environment is greatly affect the software architecture, the human dynamics, the users that are interacting with the software, and the environment in which they are operating, and the need of input, output, and the facilitating accessibility of the application, the business strategy, the business rules and enterprise organization and standards, the design of the software application, the quality attributes. The quality attributes define for the evaluation of the non-functional requirement of the application. The general quality attributes are functionality, usability, reliability, performance, supportability, and testability. The functionality is to evaluate the feature set and capabilities of the program, whether the application is performing its intended functionality or not. Usability is facilitating how easily the user can access the application. It is accessed by considering the factors such as human factors, overall aesthetics, consistency and documentation. Reliability is evaluated by measuring parameters like frequency, security of failure, as well as output result accuracy. The major parameters that can be considered for the evaluation of reliability is mean time to failure, mean time to repair, recovery from failure and the program predictability. Performance is another quality attribute. It is measured by considering processing speed, response time, resource consumption, throughput, and efficiency. The supportability is the ability to extend the program, adaptability, serviceability. So these in turn affect the maintainability, and the testability is the compatibility and configurability, which can be used to evaluate the application, easily installed and found the problem very easily solved. The structured design is the objective of the architecture. The objective is to develop a modular program structure and represent control relationships between the modules. So the program must be divided into modules and how they are related according to the architecture in order to provide the intended functionality. DFD is mapped into the program architecture. The DFD represents overall process flow of the application. It begins with the data design and then proceeds to the deviation, one or more representation of the architectural structure of the system. The alternative styles also analyzed to derive the structure that is best suited to customer requirements and the quality attributes. After that, the architecture is elaborated using an architectural design method. The features of the structured design is the type of information flow is established, the flow boundaries are indicated, DFD is mapped to a program structure. Structure can further be refined using design measures. Architectural description can be refined. The steps of structural design is the type of information flow is established, flow boundaries are indicated, the DFD is mapped to the program structure, control hierarchy is defined, the resultant structure is redefined using design measures and heuristics, the architectural description is refined and elaborated. There are two types of information flow. One is transform flow, another one is transaction flow. The transform flow is overall data flow is a sequential manner, follow one and only a few straight lines pass. Only the incoming, transform and output are concentrated. In case of transaction flow, information flow has a single transaction node that triggers other data flows. The transform flow generally consists of three components. One is incoming flow, second one transform center, third one outgoing flow. The incoming flow is the pass that transforms the external data into an internal form. The transform center is the incoming data are passed through a transform center and begin to move along with paths that lead to it out the software. Outgoing flow is the path that move the data out of the software. The features of transform flow are the system has a single and coherent objective, and the transformation center execute algorithms, data transformations, database manipulation. That means the computational processing capability is provided with the transformation center. Input demand processes filters, checks, translate external data flows, output-driven processes, format results for presentation to the environment or to the user, multiple paths to obtain the input. So the example of transform flow is consider a safe home software. So this is the transform flow. For this is the input. The control panel sensors which give the user commands and data and sensor status. This is the transformation center, and from this the output flow can be the control panel display, alarm, telephone lines. So the transform mapping is a set of design steps that allows a DFD with transform flow characteristics to be mapped into a specific architectural style. To map these data flow diagrams into a software architecture, the process would be initiated the design steps. With few design steps, the DFD is mapped into the architectural design of the software. So what are the design steps? The design steps are review the fundamental system model, review and refine data flow diagram for the software, determine whether the data flow diagram has transform or transaction flow characteristics, isolate the transform center by specifying incoming and outgoing flow boundaries, perform first level factoring, perform second level factoring, refine the first iteration architecture using design heuristic for improved software quality. So these design steps can be used in order to convert the DFD into software architecture. So here the first step is review the fundamental system model. The fundamental system model encompasses the level 0 DFD. The level 0 DFD only provides the abstract details of the project. So what are the basic input to the application? What are the computational capabilities? What services or output is produced by the application is generally represented with level 0 DFD. So level 0 DFD and the supporting information. In actually, the design step begins with an evaluation of both the system specification and the software requirement specification. Both documents describe information flow and structure at the software interface. So consider an example of safe home software. During the first step, level 0 DFD of the safe home software. So here this is the processing capability. For this, these inputs are given and these are the output. So level 0 DFD only produces the abstract details without the detailed implementation of computational capabilities. Next, the level 1 DFD is used to explain elaborately how the information flow exists in the application. So, as soon as the control panel is initiated, the user commands and data, it can interact with the user and accessing the password and process the password. And if at all the interacting user, the configuration of system takes place according to the database stored configuration information, and the interact with the user can activate the descriptive system, as well as the process forward passwords can validate the users so that the display messages and status process can be activated. The other input alternative is the sensor data. The sensor status is given to monitor sensor process, which will fed to the display messages and statuses. So from the database, the configuration data is taken as input by the display message status, and the output must be produced as control panel display, alarm and telephone line. So in detail, the process has to be present in the level 1 DFD. But from level 0, only the abstract details of DFD must be present. The second step of transform mapping is review and refine data flow diagrams for the software. So information obtained from analysis model contained in the software requirement specification is refined to produce the greater details. So the level 2 DFD for monitor sensors is examined and a level 3 data flow diagram is derived. So at level 3, each transform in the data flow diagram exhibits relatively high cohesion. The process implied by the transform performs a single distinct function that can be implemented as a module. So cohesion is the single-mindedness or the degree how the module can perform its intended functionality. Therefore, the DFD contains sufficient details for first cut at the design of the architecture. So this is the design of the step 2 from the previous levels of level 1 DFD. This DFD can be achieved. So here only the axis against the setup is the central transformation, the information process flow, which can take the database from the configuration data and sensor status from the read sensors and form at for the display the sensor ID type location and generate alarm signals which can be the output of alarm status. Telephone numbers dial the telephone is the output. So for this information flow, 2 inputs are taken and 3 outputs are producing. The next step is determine whether the DFD is transform or transaction flow characteristics. In general, information flow within a system can always be represented as transform. So, however, when an obvious transaction characteristic is encountered, a different design mapping is recommended. In this step, the designer selects the global flow characteristics based on the privileging nature of the DFD. So, in addition, local regions of transform or transaction flow are isolated. These subflows can be used to refine program structure derived from a global characteristics. So, the resultant design of step 3 is enhancing the read sensors and acquire the response information, establish alarm control and select the phone number, set up the connection phones and generate the phone numbers to dial. So, like what are the sequence of functions that can be performed for the transform mapping are identified from where this data must be performed in a sequence of activities which resulting where it must take the input and what are the 3 outputs that can be produced from this transform mapping. So here if you consider this part, the 3 inputs and the sequence of actions, the output functionality are concentrated. Design step 3, evaluating the DFD. The data entering the software along incoming path, exiting along outgoing 3 outgoing paths. No distinct transaction center is implied. So therefore, an overall transform characteristic will be assumed for information flow. The next step is isolate the transform center by specifying incoming and outgoing flow boundaries. So in the preceding section, incoming flows were described as path in which information is converted from external to internal form. Outgoing flow converts from internal to external form. Incoming outgoing flow boundaries are open to interpretation. In fact, alternative design solution can be derived by varying the placement of flow boundaries. The next one is perform first level factoring, program structure represents a top-down distribution of control. So without affecting or alternating the architecture, a small change must produce the tremendous or optimizing the output is generally referred as factoring. So from the previous level DFD, first level factoring must be performed at this step. Factoring results in a program structure in which top level modules perform decision making and low level modules perform most input, computation and output works. Middle level modules perform some control and moderate amount of work. So the design step where the previous architecture is this. From this, the information centers must be identified according to the functionality. The top level architecture must be considered. So here the sensor alternatives must be the top level. From this, sensor input controller, alarm control, alarm output are the submodules. Design step 5. A main controller called monitor sensor executes, resides at the top of the program structure and coordinate the subordinate control functions. An incoming information processing controller called sensor input controller coordinate receipt of all incoming data. A transform controller called alarm conditions controller supervises all operations of data in the initialized form. An outgoing information processing controller called alarm output controller coordinate production of output information. So these are the three functionalities from the top level functionality. The next step is perform second level factoring. Second level factoring is accomplished by mapping individual transforms bubbles of DFD into appropriate modules within the architecture. So beginning at the transform center boundary and moving outward along with incoming then outgoing paths, transforms are mapped into subordinate levels of software architecture. So in this step, more detailed structure must be performed. In that level design step 5, only until the alarm monitoring issue must be identified. So after that, the control flow of these rest of the DFD must be considered in order to elaborate the software architecture. The further modules are the display, generative alarm signals and the setup modules, which can have other submodules. So depending upon following the DFD process flows, the modules in the architecture are identified. So 2 or even 3 bubbles can be combined to represent one module and a single bubble may be expanded to 2 or more modules in the design step 6. So practical consideration and measures of design quality dictated the outcome of the second level factoring. Review and refinement may lead to changes in this structure, but it can serve as first iteration design. Factoring is again accomplished by moving outward from the transform center boundary on the incoming flow side. So the second level factoring, so more detailedly the output must be concentrated. What are the submodules in the 3 identified modules during the design step 5 are elaborated in the next step. So refine first iteration architecture using design heuristics for improved software quality. A first iteration architecture can always be refined by applying concepts of module independence. So coupling and cohesion are majorly concentrated during this step. Modules are exploded and enfolded to produce the sensible factoring, good cohesion, minimal coupling, and most important, a structure that can be implemented without difficulty, tested without confusion, and maintained without grief. So the last step is the design step 7. Software requirement coupled with human judgment is final arbiter. The incoming controller can be removed because it is unnecessary when a single incoming flow path is to be managed. So the substructure generated from the transform flow can be imported into the modules establish alarm conditions. So the modules format display and generate display can be imported into a new module called produce display. So here the alarm actions must has to be synchronized and those can be combined as produce display in the next level of iteration. So the objective of preceding 7 steps is to develop an architectural representation of the software. From the data flow diagram, the software architecture must be represented. That is, once structure is identified, evaluate and refine software architecture by viewing it. So modifications made at this time require little additional work, so which can give profound impact on software quality. So consider another case study, that is a software system called root main square calculating system which reads 3 integers in the range from -1000 to +1000 and calculate the RMS value, then display it. Apply transform analysis to design its architecture chart. So the context diagram, that is the DFD level 0 diagram. This is the processor RMS calculated. So from the user the data items must be received and it can produce the RMS. Level 1 DFD more clearly describe the processing capabilities of the application. So validate the input is the first process which receives data item. Validate data after compute the mean square is the second process, and M square is given to the display result so that the output must be given to the user. Level 2 DFD is the square of A, B, C, 3 numbers are given and the mean must be calculated. The root must be calculated so that the root mean square value must be generated. The structure chart of this RMS is main program. So get good data, validate the data, compute the RMS, write the result or display the result. So while reading the data items read input, validate the input or the submodules. So like this, how the DFD is mapped to the software architecture with the transform mapping is discussed in this video. The references used in this video are this. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.